Gagamitin mo yung
Napalis mo naman. Mathematics. May experience. Minsan, pagkulit-ulit. Nahihirapan ko. Stress rin ako. Ganun marami. Kasi ano nga? Ay, parang nalang ko lang. Yan yan. Luto ko. Ito na ba niya? Okay, very bad. Allora, simulation ko. May lang rin sinunod lang. Saan gagamitin mo doon? Hindi pwede nga. Wala na siya. Ano? Hindi wala. Yeah. By the way, use one of our so we did not pass through this presentation. Two other locations. One is the transparent and the other one's in warehouse. So we have set up so they will move. It allows us to for our classes places in the Philippines. If, yeah. Try to catch your breath. Yes. It's the first time I'm here in the Philippines. Okay.
First time here.
Really? Okay. It's funny. You have an HDMI?
Yeah, I do right over here. So.
Power? Yeah.
Genset natin. Ayan. Yan.
You guys get in the Philippines?
I've got a cheater if I need. No, it's
So this is
a 3 to 2.
Hello, magandang hapon po. My name is Michelle. I'm the Information Officer for TPE. Magandang hapon sa inyo lahat. Thank you for taking the time to join us this afternoon. We are also streaming live to universities in UPLE and also in UP Baguio. So, you can give a hi to them. So there. We have from ADI, so they're just setting up the presentation right now. We're turning on the microphone for them. So if you like to sit back, relax, and we'll present it.
Good afternoon. Good afternoon. How are you? My name is Brian Severis. I'm the design engineer director from Untitled Devices. And as you know, Analog provides high performance analog and mixed signal solutions. And you probably know us by the laboratory that we donated here on the other building. There's a couple of them with big signs, so that's the one. And just recently, maybe a year or so ago, we acquired the best power company ever. And that is the linear technology. We are proud to have here a couple of legacy LTC folks. Well, he will sort of give us a lecture on Ltspice, and just quickly Eric Welde, Director of Industrial Power Systems. Eric is responsible for providing system-level power management, design support across ADI Industrial Technology Groups and Field Technical Support Group. Eric brings over 20 years of system power design experience from his previous role of field applications engineer for the southeastern United States. Both Eric and James here come from North Carolina. I'd like also to introduce James Staley, Manager, Industrial Power Systems. James is responsible for providing system-level power management, data science support, across API, industrial and healthcare technology groups, and field technical support. And James began his career with the Power Applications Group in 2000 to Dr. Donian Zhu. He went on to become the first applications engineering sales and held that role in the Southeast sales team. So the presenter today is Eric Welde. Perhaps you can describe the course, and it's about Ltspice, the high-performance spice simulator that is going to
So for this afternoon, Eric will introduce participants to the Ltspice simulator tool and how it can be used by students to design, simulate, and validate circuits using amplifiers, switching regulators, amplifiers, as well as a library of devices for general circuit simulation. Without further ado, we bring to you Eric Welde, for Industrial Power Systems Analog.
everything.
Good afternoon, y'all. How's everybody doing? Everybody's complaining about the heat here. I'm from North Carolina. I called my wife yesterday. She said it was 33 degrees. So, kind of cool here for me, but a little humid. So, this afternoon I'm going to discuss the spice tool we have called Ltspice. This is a free download. You can download it and run it on your PC. It is the world's most widely downloaded spice program, and there are a lot of tips and tricks in it. So this afternoon I'm going to cover the basic course. I'll leave this PowerPoint and a bunch of the examples that I'm showing with Richard, along with some other course material, and that will allow you to better be able to use this program. So why use Ltspice? Well, it's got an unlimited number of nodes that you can simulate with. Okay, it's a schematic and a symbol editor. It also supports hierarchical schematics. Not a lot of spice programs do that. There's a waveform viewer and a fairly large passive library for caps, inductors, MOSFETs, and things like that. It is a fast simulation tool. It's one of the fastest things on the market. We've done a lot of things to optimize it for whether you've got a dual core or multi-core. We try to use all 4 cores. It does turn-on transient. It does step response, and it will do the efficiency and power measurements. On top of that, it also does a bunch of advanced stuff that we won't cover in this class, but I'll leave with Richard so you can refer to it later. It outperforms most of the pay-for tools. I've had a number of customers who have said, I'm going to drop my pay-for tool because this does everything I want. We allow you to import third-party models, so you can use parts other than analog device parts, but we prefer to use our parts, but if not, you can import other people's parts. So to get this tool, how do you get the documentation? You go to www.analog.com/Ltspice. It is a free download. Okay. Left click on the download for 7, 8, or 10 Windows, and there is also a previous version for Mac, but it hasn't been updated as much as the other ones. Okay. Ltspice is a standalone application. It is not a web-based application, so we can't see what you're doing. We like that, so you can keep your masterpieces private. At this link, you'll be able to see a bunch of demo circuits, okay, Ltspice documentation, and also a list of technical articles and videos and a bunch of spice models. How do you get started using Ltspice? Demo circuits. When you go to the analog web page and you plug in a particular part number, you will see right here, you can plug the part number in, and you go to Tools and Simulations, and then it will allow you to download that file. When you download the file, it's going to look something like this. You need to double check the file to make sure it's right. The demo files were done by the applications group, so they've all been verified and everything's fine. What if you can't find the Ltspice demo circuit? We have what's called a jig file, or jig. So these are simulations that are used by the modelers to test the validity of it. So sometimes the schematics are not 100% accurate, but it's a way to get a pre-drawn schematic. So when you call up, you hit the AND gate, okay, you then type the part number in and then hit open this macro model, and it will draw your standard schematic. It'll pull up the standard test schematic for you. That's what the standard test sheet would look like, and you can then simulate from there. Okay? New components in Ltspice library, it includes 80 and 80p power parts that will be loaded. We're slowly loading the entire product line. Okay? The other thing, there is a users group on Yahoo. If you want to, it's Ltspice, and there are a number of free circuits up there that you can get to and try stuff. It's also a pretty good open forum if you've got a question on how to do things. We do monitor it and tend to give answers. Okay? What happens if you can't find it in those 4 locations? You start with a blank schematic. So using the schematic editor in Ltspice is very, very easy. It's kind of intuitive. We've added a couple tricks to it so the schematic capture is faster. Any questions? I'm sorry, I'm going kind of fast here. Everybody good? If you guys have questions, stop me, because I tend to go a little too fast, and I'm sorry about that. So normally we would complete an exercise. I'll leave these files with you so you can play with this, but we're going to end up drawing this circuit, okay? And when you go across the top of the toolbar, you can see that there are a whole bunch of commands that you can get to. Just about all of the picks across the top also have a key click. If you go to the Ltspice section of the analog webpage, there is a shortcut that gives you a summary of what all the key clips are if you want them rather than using those. So the way to start a new schematic is you say File New Schematic. If you want to add a resistor, you hit the resistor symbol and drop it. If you want to add a cap, you hit the cap symbol and drop it. And then to add a component like a voltage source or an op amp or a power part, you hit the AND gate, and from there you would type voltage and it would bring up a voltage source. After you do that, you hit the wire button, and this is the unique feature of Ltspice. So essentially you go from the ground across B1, up across R1, and down to C1 with a click at the 4 corners. And you can see the steps it goes through: up, stop, over and stop, down and stop. And it shows shorts over all of the components, right? Well, once you hit stop, it removes all the shorts. So it knows that you meant to connect those and not short across them. Okay, so that makes drafting a schematic significantly faster. Okay, the next thing you'll want to do is labels. That's the little A symbol up there. And you'll label in that in, and another one called out. What that does is when you call up the waveform viewer, rather than getting a node name, you would get what's the input voltage, say V bracket in or V bracket out. And that way you've got a way of knowing it. If you don't label those nodes and you want to search for where a particular node is, and all of the nodes are N001 to however many nodes you got, there's a little set of binoculars up there, and that's where you search for a node that you're looking for. Next thing you want to do is select the component values. So if you right-click on R1, it's going to bring up a table that shows you can put the resistor value in. and then you can say select resistor, and it's going to pull the standard 1% resistor values up for you, and you can double click on that and put it in there. So if you've calculated a value that's not a standard value, this will let you know what that standard value is. One of the big things in Ltspice that catches everybody, M for us, capital M, lower m is milli. Okay? Now, you would think that we could distinguish between those two, but for us, megohm or meg is MEG. So if you have a mistake, that's probably it. That's the number one mistake that people make. So once again, upper or lowercase m is milli, and MEG, either upper or lowercase, is meg. When you right-click on the attributes of just about all the parts, resistors, inductors, caps, diodes, we have a variety of parts that you can choose from. When you change to a polarized cap, it adds the little polarized symbol on the cap itself so you know what type of cap you put down. The same way on diodes, we have Schottkys, Zeners, a whole list of other diodes, including LEDs, and we change those symbols so you know that, hey, that's a Zener diode, that's a Schottky diode. Okay? When you hit select inductor, in this case, it's going to give you all of the standard values. You can search these tables by either the value, the vendor, or the current. So that's a pretty neat feature if you're looking for a basic part. We try to keep these models updated. We don't necessarily do the maintenance. The vendors that provide these models to us, it's their responsibility for doing it. So next you've got a voltage source. This voltage source window will work for both current voltage sources and for loads. So you can define either a DC load, a pulse load, a sine wave, an exponential, a piecewise linear, or we allow you to import a wave file in. Okay? So if you're doing audio stuff and you've got a wave file, you can import that data into here and use it to simulate against what you're actually doing. This is a very powerful feature. When you click down into it and you say pulse, it tells you what all the variables are. So you can just look at that rather than having to remember what the syntax is. Running and probing circuits in Ltspice. So after you've drawn your circuit, you hit the run button, and the run button is the little man who's doing this. Okay? That's run for us, okay? And to halt it, it's the halt command. Okay, so that's run and stop are the two different things. Once you run this, you're able to go in and actually measure current and voltage on the fly. So you can see a little voltage probe up there. On this next one over, you see that that's V bracket out because that's the net label that we labeled out. And then, then if you want to see the current, the little current symbol that you hold over, okay? And that's over a specific component. Now, if you have a series of capacitors and you want to know how the current is distributed along that wire, you hit the control key and it allows you to measure the current in a wire. That's a very unique feature. Not a lot of people can do that particular feature. We also allow you to add multiple plot planes. You can run this on two monitors. So you can have the schematic on one and a plot plane with as many plots up there as you want. You can also have more than one plot on one plane. We try to do single plot, single plane, so you don't get confused with things. So we have a voltage probe and a current probe, and you can see those, and that's what those are. The other thing that you can do in the waveform editor, if you want to know what, say, voltage at A, node A, and voltage at node B, if you multiply those two together, you can actually do trace math inside of the waveform viewer. So it's kind of as clever as you want it to be. The part does AC analysis. It finds the DC operating point first. So in this particular case, we took the AC, or the voltage source, and changed it from DC to AC. And then we added a statement down here that says, measure AC on the 3D point when V out is equal to 1 over the square root of 2, because the voltage source is 1. So you would then change your AC analysis to decade, number of points per decade, your starting frequency and stopping frequency. You hit OK, and you get a nice little waveform like this. The dashed is the phase, and the solid is magnitude. Okay. We also can do Bode plots with op-amps. It's kind of limited to what your creativity is. Any questions? Everybody good? Everybody still awake? I don't think so. Defining a component value as a variable. How many times has somebody said, hey, I want you to analyze the circuit, but I want it with a 10K, a 20K, and a 30K value. This is a way of letting the tool do that for you. So in this case, we change the R1 to bracket capital X, and then we come in here and say dot parameter X is equal to 10K, which is all fine and well. When you run that, it's going to come out and look something like that. No big deal there, right? That's kind of ordinary at that point. So now if you do dot step the parameter X, I want it to run from this list of 10K, 20K, 30K. When you run it now, it gives you all three values. So you can see how things change. And there are a number of different ways of defining the parameters. There's a range with step size, or a list, or whatever you want it to be. Questions? Running DC converter simulations and analyzing the circuit performance. So when you look at a switching power supply, there's quite a bit going on inside. There's typically a switching adapter, an input source, some sort of load on the output. You notice I1 is the actual load, which is a load of 3 amps. That's a steady state load. You can go in and do transients on there, and I'll briefly show you how to do that later. So you run the output, and you probe the output, and it kind of starts up, and then it reaches steady state. This particular sweep takes about 20 seconds to run, but because it's analyzing all the stuff inside, and that's really fairly quick if you've ever done power supply design. We can then go and probe the inductor current. So what the inductor current look like, which you should see that ripple on there. And if you're not sure, you hit the output or the magnifying symbol with X, and that zooms to the full extent of what the plot is. Okay, you can then right-click for attach a cursor. And you can attach 1 or 2 cursors, and then it's going to give you the difference on the plot plane. And then it will give you dx and dy values between the 2 different points. The other important point here, you will see the little black probe, okay? That means you're going to be measuring a differential between 2 things. So the black probe defines 0. And the next point you pick is the voltage you see between those 2. It is not referenced to a ground. It is a differential probe. Yeah. Okay, steer me last side. So that's a very powerful tool if you want to be able to measure differentially across things. You'll see when you right-click on that node, it'll say mark reference. That's where you set 0. You can also plot power in wires or current through wires. And you do that with the Alt key and left click, and you can see where they're plotting multiple points of current through the wire. Okay, next we can also get the average and RMS value. And you zoom in to the extent, and whatever you zoom to in the waveform viewer, what you want to do is do a click, a control left click, and it gives you this dialog box here that says over this interval, the start and the stop, the average current is this, and the RMS current is this. So that's the means of calculating that stuff fairly easily. You can also get the instantaneous power of what's inside of the device. So to get that, you hit the Alt key over the device, and it's going to change the probe from either current or voltage to a little temperature probe, which is power. And then that tells you how much power is in the device at that particular time. And what it does is it runs all of the math for you to figure out how much energy is going into each pin and how much is going out, and it gives you a total of what's left in the device. Delete waveform, you can right-click on the waveform and just hit delete, or you can double-click on one trace and it'll clear everything else out. You can also do delete traces, and it pulls up a dialog box and shows you all of the traces, and you can delete the ones that you don't want on there. And the other way is to click things twice, which is what this example is showing you. Net labeling. So you can see where these nodes are labeled VN004. That's because it's not labeled. If you want to know what that node is, use the binoculars, and it will highlight in yellow the tree that is referred to. This is exceptionally useful if you're running a schematic for the first time and it says convergence issued in 2001. What's that? Okay. Well, if you use that search feature, it'll show you where it's going to. And in this case, N004 is the output. So, okay. Next thing is generating an efficiency report and a BOM for a particular design. So what you do is you say view, efficiency report, show on schematic, and it pulls this type of picture up for you. It says here's all the caps and voltages that you've chosen, and if you've chosen specific vendors, it will populate with what the vendor part numbers are. I believe there's 2,000 capacitors in the database, so there's quite a few there. Next, to find steady state of a power supply or any other device, you say stop simulating if steady state is detected. So there are good and bad loads for how you determine this. Resistors are bad loads. Yep, all of these others work fine. Okay. If you look in the one in the bottom right-hand corner there, the I load, where the little square box, that is an actual load symbol, and it will only pull current in. The other current sources, if you define those backwards, it will pour energy back into the power supply, and your simulation won't work very well. So next you run this, and you'll reach steady state, and then you say show efficiency report on schematic, and it tells you that your overall system efficiency is 86.5%, and it tells you which components are consuming the most power. And then go in and try to choose better parts to make it better. Switch mode power supplies can be tricky, and so there are several tricks to it. If it doesn't reach steady state, we have the option of marking the start of a steady state and the end of a steady state, and the part will calculate it based on that. Okay? Probe the various nodes in the circuit to make sure it's stabilized. If your output is oscillating, it will not find steady state. For multiple outputs, it's often very hard to determine what steady state is, so you have to do it a single load at a time. Doing them all at once is not easy to have it automatically automatically calculated. You can play tricks with calculating it yourself if you want to. Okay? If the circuit has not stabilized after a very long time, there are a couple different methods of solving that you can get to with the little hammer symbol, where there are 3 or 4 different solving methods, and often changing the solving method will cause it to stabilize better. Simulating a transient response. So we're going to change our load symbol and make it a pulse load. So our current waveform will look like that. So you define the a pulse load, and then the other thing is say that this is an active load, so it will not start to pulse before it's got the joint. Otherwise, it's going to do some bad things in the design. So we then run it, and we look at the current, and we pulse it, and you can see the dip in the output voltage. We do allow you to import third-party models. Okay? Download SPICE files from the manufacturer's website. Place the SPICE mode file in the same directory where the Ltspice file is. Open the SPICE model file and make sure to make note of what the name of the part is you're doing. You have to match the syntax exactly. It is case sensitive. So if you don't match the case exactly, it probably will not find that model. Okay? Then you do count include what the SPICE model file name is, not what the model is you're referring to. The following is crucial. The name in the .include statement must match the SPICE file name identically. Upper and lowercase spaces, everything. The device name on the Ltspice schematic must match the device name in the SPICE file you've referred to. So there's 2 syntax hitches here. Be real careful on that. I've been hit by that several times. And in this case, we've got the file name is 1N5244B, and the model name is 1N5242B1. A little difference there, so it would be very easy to leave that 1 off. The other item is there's one called Joe.text, and the SPICE model is Everest. That's fairly clear because they're different enough that you shouldn't have an issue. When you go in and do this, you navigate to open up that Zener and change that model name to what you call it, and then you do the count include statement, and you run it, and it should simulate right for you. Questions? So this is another case where you're just going to have a count include file. Should I change mic?
Better.
All the scratchy go away. Is that better, guys? Yes. Okay. So in this particular case, we do the count include file, we change the dial name, and we rerun the simulation, and everything turns out well. Importing third-party models, you can create your own symbol if you want to. You can tell it what the sub-circuit name is, and it will automatically draw the symbol for you. It'll often be something like this, which the pinouts may not be what you want, but then you can go into the symbol editor and rearrange that and draw that any way you want to. But this is a means of making sure that all the pins in the sub-circuit are wired out. And here's a final implementation where we did the model for an 8237. We included a 8237 circuit, generated it, made the op amp. More information on support. We have a couple other power supply design tools. One of them is called LT PowerCAD. You use PowerCAD, you go in and say, what's my input voltage, what's my output voltage and current. Hit search, and it will generate a list of possible parts for you. Choose the parts you want, and then it'll help you with all of the calculations, is how much inductance, how much tap, what the switching frequency is, what's the power loss, how to calculate what the load step response is, what the frequency response is of the power supply. It's a pretty useful tool. We also have an analog filter wizard and a pretty good photodiode circuit wizard. It is important to do a sync release with Ltspice about once a week or every time you use it, as we update it 3 to 4 times a week with models and bugs that we found in things. So this will work in Windows 7 and 8. You must run it as an administrator, okay? And then that will allow you to update it. Windows 10 doesn't have that issue. There's also the software update and a sync release for a Mac. And then there's a pretty extensive help file. And that's kind of it. Questions, comments? Have I bored you to death?
Any questions? Doon na kayo guys, minsan lang tayo may previous. Are there any details in the presentation you'd like more clarification? I think we have Eric here for another maybe 15 minutes.
So what I'm going to do is leave a bunch of training material that talks about how to do piecewise linear source, control current switch, voltages, and a lot of the more advanced subjects. If I teach that in a class, it's about 15 hours of work, and I don't think you want me to talk that fast. So I'll do all of that stuff and send it to you. That way, hopefully, you can post it on a network drive and people can get to it and use it. The thing with these presentations, it's got the PowerPoint and it's got the actual example splice circuits. So you know how to do it, so you can follow that syntax, and that works fairly well.
I think we can receive questions from the other sites where we're streaming. Muriel, our student assistant here, is coordinating with them to see if they have any questions that we can intervene right now. Otherwise, we can turn over to
Distortion analysis. How does Ltspice handle distortion analysis? Switching.
It's done as a transient.
It's back, the scratching.
It's done as a transient. Oh, he wanted to know how we would model the distortion, and you would do that in a transient analysis, or if you're doing it in the AC domain, then you would vary a parameter to simulate what the distortion would be. That is the adding factor.
The questions from the other participants that we have on the streaming side. Are you sure you don't have any questions for Eric?
Yes, we can ask who uses Ltspice.
So who all uses Ltspice?
Who here uses Ltspice? You, sir. Fourth row, first seat to the left. No, we're putting on the spot. Yes, you. What has your experience been so far? So this is the adoption part of the presentation. Yes, you.
No.
I use once in one example power supplies. I use it for the documentation of the simulation. I always convert so a question, since Ltspice is power to download, is there any other limitations on it regarding on how the user would use it? If we will plans to use it in business or something, does it need to
the rules of engagement for universities are free to use it all you want to. If you work for a complete semiconductor manufacturer, you are not allowed to use it, and that is a violation of the contract and part of the terms that you accept when you use the program. Is we diligently pursue it with the
This will be required for commercial uses. Restricted, of course, so you can take advantage of using the app for your school. Any other students here who also use Ltspice and who would like to share their experience? Very shy.
Thank you.
With that, let's all thank Gary for the presentation. Thank you very much.
I left the certificate in the room. It's in the envelope. I think this is not the first time we'll be hearing from Ellie. I think this will be part of the series. And we will be doing it again sometime this year. Hopefully.
Yeah.
Oh, sorry. Yeah.
So later in the year, Mike Engelhardt is coming. Mike is the gentleman that wrote the software, and he's got a whole bunch of tips and tricks and all that stuff. He moves faster than I do. Okay, so be forewarned. He's an excellent teacher, and he knows a lot about this tool. It's just to give you an idea how many people are resourced for this tool. Mike does the software, and there are 2 people that do models full-time, and then there are a couple people in GT that do it. So it's not like there's 50 people doing it. It's less than 5 people total, I think, is what it works out.
So regarding Ltspice, we will continue this platform in the moment. As we try to execute some of the newer labs that we will be rolling out. So we've come up with integrated laboratories where we're actually trying to converge ideas with regards to circuits, programming, and then trying to see how Ltspice can work together with MATLAB, especially for post-processing. When that's distortion, we're trying to introduce distortions into the circuit and then run Ltspice to be able to give that distortion and see what the actual output would be. So as Eric said, he will be sharing the materials that were presented here, plus a number of more exercises that we will be sharing with you. So as we move along with the curriculum, feel free to start using it. As he said, it's free. You can easily download it as part of the academic unit, so we can easily start playing with this particular tool, so you can learn more about the circuits that you're actually learning in your classes. So before we end, I'd like to give this certificate of appreciation to our guest, Welde, sorry. For sharing knowledge and excellence in this talk, we invite the introduction to Ltspice, analog devices, high-performance spice simulation software through schematic capture and waveform. Given this 25th of September at the National Innovation Lecture Hall here at the Liberty Institute. And with that, thank you very much for taking it. So, last questions, guys. Come on. Come on with this. Did you use Ltspice applications? No?
Yes.
Why not?
Maybe we can
It's
explore
a way of
some more.
solving all of your circuits questions. You can just leave it, come back later, and it'll give you the answer.
Especially for the switching components we need to look at. Purpose. Value depending on the symbols that you have. How many are connected to the power lab? Who's taking the one-to-one? One-to-one?
121?
Come on, show guys. Don't worry. Hindi ko kayo just a show
I
guys.
was gonna put you on the spot.
Don't worry.
Later.
Who's in their first year right now? First years?
We have freshmen in the crowd
Wala. Who's doing 53?
who would like to admit to it.
Who's doing 53? Come on.
We have
So yeah, so we have a lot of students that do teaching right now. Power electronics. 1, 2,
Or electricity.
3. Okay. Some of the students are actually working on a different package. So maybe they're using symmetrics, or they're using, well, some of the students that we have in MyClub would use cadence instead. So it's a different mix. But anyway, as we roll out the new curriculum, we look at Ltspice in our instruction. So with that, let's thank our guests for coming all the way from. Thank you very much.
So what's going to be the best way to get all this spice stuff in? Because it's too big now. Do you guys have an FTP stick that you could pull off a Lego and send to him?
I'm not sure. University.
Miles. How can we
That was so big.
There's a bunch of them. There's like hundreds of them. Yeah. I can send you